Question number 7. We've been given a curve which is defined by the equation x cube plus y cube minus 3xy is equal to 0, and we need to find the coordinates of point P where the tangent line is parallel to the y-axis. So firstly, let's start by differentiating both sides of this equation with respect to x. So the derivative of x cubed with respect to x will be 3x squared plus the derivative of y cubed with respect to x will be 3y squared times dy dx using the chain rule minus 3, and to differentiate x times y we need to use the product rule. So if I let u equal x and v equal y, the derivative of u with respect to x will be 1 and the derivative of y with respect to x will be dy dx. So the product rule is u v dash plus v u dash. So u v dash is x times dy dx, so x dy dx plus v u dash, so y times 1 which is just y, and this is equal to 0. Now let's expand the brackets. So we have 3x squared plus 3y squared times dy dx minus 3x dy dx minus 3y, and this is equal to 0. Now we have 3 in all of these terms, so we can factor out 3 and cancel it with 0 by dividing it underneath. So we'll be left with x squared plus y squared dy dx minus x times dy dx minus y, and this is equal to 0. Now I can factor out dy dx from these two expressions. So we have dy dx inside the bracket y squared minus x, and I can move x squared and negative y to the right hand side of the equation. So we have y minus x squared. Now we can solve for dy dx. So dy dx, this is equal to y minus x squared upon y squared minus x. So now the question has told us that the tangent is parallel to the y-axis. Now the gradient of y-axis is undefined. So if the tangent is parallel to the y-axis, its gradient will also be undefined. So now that we have an expression for the gradient dy dx, so when will this be undefined? This will be undefined when y squared minus x, which is the denominator, is equal to 0, because anything divided by 0 is undefined. So what we can do is we can equate the denominator to 0 to make the gradient undefined. So we have y squared minus x equal to 0, from where we find the relationship that x is equal to y squared. Now using this relationship, I can substitute y squared for x in the original equation for the curve. So we have y squared to the power of 3 plus y cubed minus 3y squared times y, and this is equal to 0. I have substituted y squared for x in the original curve equation. So we have y to the power of 6 plus y cubed minus 3y squared equal to 0. So y to the power of 6 minus 2y squared, 2y, this will be 2y cubed, so minus 2y cubed is equal to 0. So from here I can factor out y cubed from this expression. So inside the bracket we will have y cubed minus 2, and this will equal 0. Now using the null factor law, I can solve for y. So either y cubed can equal 0 or y cubed minus 2 can equal 0. So y is equal to 0 and y is equal to the cube root of 2. Now notice that the point P does not lie on the x-axis. So y equal to 0 will not be a solution. So this is not a solution, as we can see from the graph. So we have found the y coordinate, which is the cube root of 2. Now to find the x coordinate of point P, we can substitute the cube root of 2 for y in this relationship that we found. So we have x is equal to the cube root of 2 squared. So I can write this as a rational power as 2 raised to the power of 2 upon 3. And similarly, I can also write this as a rational power as 2 to the power of 1 upon 3. So we have found the x and y coordinates of point P. The x coordinate is 2 to the power of 2 upon 3 and the y coordinate is 2 to the power of 1 upon 3. So this is how we solve question number 7.